Swayam Prabha. Digital India. Educated India.
So is it okay? Shall we start again? Yes, sir.
Yes, sir.
Sure, I think
Yes, sir.
Oh, okay, so I hope all of you are here. Yeah, this is taking the attendance. So tells me when you are coming in and going out. That is good. Okay. So what we are doing, what I thought is usually I write a lot on the blackboard or the board. So what I thought last few days I got for myself something like this. There is a okay, I have to share the screen. Just a minute. Share the content and screen. You have to tell me if you can see it. Okay. I think. Can you see this?
Yes, sir.
Yes, sir.
Okay. Now what I think I'll do is I'll write on this. Hopefully it will be as good as we can get. That is the best we can do. Let me see. Okay. So this helps me to write on this. I hope you can see now. Is it clear? Hydrostatics and
Yes, sir.
okay. So what I'll do is I'll try to write on this, and the usual blackboard will be replaced by this. So we'll work with this. Right. So the course is hydrostatics and stability. Not very easy to write on this, but it's okay. Yeah. So what we will be doing is basically first we will be dealing about the details of the ship. Let us go slowly. This part you should be very clear because the rest of your course in naval architecture will depend upon this. So details of the ship. In marine construction and welding, you will learn about the ship structures. There will be a little more on the details on the structures of the ship. This here we are talking about the main details of the ship, then the principles of flotation. Principles of flotation. As you might be aware, there are rules like the Archimedes principle form. I mean the laws like the Archimedes principle and the Stevin's theorem, which is we are going to do all that anyway. So we'll do the principles of flotation. Then we go to what are known as the conditions of stability. So the conditions of stability. These are the basic conditions of stability for a ship to float upright. So till now we did mention that the ship should float. First, of course, the ship should float. That is the first thing. But it is also important that the ship floats upright. So you can, you cannot have a ship if it is like this. It cannot float like this all the time. So that is not allowed. So you have to have a ship that floats upright. So this is the upright condition. So that is one thing. Those are the conditions of stability. We will come to things like GMBM, all those things, a lot of things on that. Then we will go into more advanced, a little more advanced conditions of okay. So more advanced conditions of stability, and we will deal a little bit about waves, and we'll finish the course by then. Now. We need to figure out how to do the grading this time. You know how the grading is left to us this time. It's called a continuous evaluation process this time. Now what exactly it means, nobody is clearly defined it, but it means something like probably I should give assignments as the course goes on, and there will be no mid-semester, there will be no end semester. You know that. Other courses, they would have told you that already. Now tell me, what do you want? What should I follow for assignments and all? Is that what you would like to have? Assignments like every week, one assignment or something like that? Is that what you want?
Yes, sir. That will be fine.
That'll be fine, no? Okay, the only thing is that this week I cannot have because I haven't yet figured out how to use the assignments module of this MS Teams. So, but what we'll do is we'll have assignments. I will say maybe attendance will carry some marks, definitely. Some 20 or 30% marks can be for attendance. So you attend all the classes, then some we'll have some assignments. So continuous grading in that sense. Now how to do that assignment part is still I have to see. So we'll go into that next week. By that time I will figure out probably how to deal with that. Okay. So what we'll do today is we'll just introduce ourselves to the course, the basics of the course, the hydrostatics of the course, basic hydrostatics. So as I don't know if you can see it, but I have put two class materials, like two class materials. I have put two books there. Now where to see that, I am not sure. I hope you can see that. One is, so basically, so two books to be used. These are the two basic standard books in hydrostatics. The first one is a book called book by Adrian Biran. Adrian Biran. It's the author's name, and it is a book on ship hydrostatics and stability. That is the name of the book. So actually, I have opened that book here, and so I'll be going through that. You cannot see this, but I'll go through that in that or from this, and I'll just explain it here. That seems to be better for me. Then there is a book by called Merchant Ship Stability. This is by an author named Lester. So it is by this book is basically got a lot of problems, a lot of worked out examples. So what you can do is, if you have the book, if you cannot take the book from here, I'll email it to you. It's not a problem. That's what I usually do. But I think you can pick it up from here. I have put it in the classroom materials. So you have this merchant ship stability is basically got a lot of worked out examples, and what I do is for my assignments, we used to have assignments last year also. We had a continuous assignments, but main portion of the marks were for the mid semester and end semester. That's all. But we had a section for assignments, but this time it will be completely that assignments. So we'll do that. So those assignments, the problems I mainly take from this merchant ship stability book. So I strongly suggest that you take a look at this book. It's got a lot of problems. So if you will have to sit and solve all the problems, I'll do many of the problems in the class. So as we go on, because I always find that you get more, you understand the subject more, or you seem to get a grasp of what I'm talking about more when you do these problems, rather than just explaining the details of this subject. Okay, so these are the two books that we'll be using. So I have here the book Adrian Biran. So I have opened that up. Let us start from it. So basically, this is, first of all, we go for what we call as the basic marine terminologies. Marine terminologies. So as you can see, we usually draw a ship, and this is where the water is. So this is how you usually represent in this course. From now on, we'll represent it like this. We will. This is the ship, and usually you write here WL. This stands for WL stands for water lines. Okay, water line. It is the region where the the air and the water, that height, that region is known as a water line. In this, as you probably wouldn't have done, but you know that there are a lot of waves also in the ocean. You know, there are a lot of waves, and they produce a different style of problems in case of this. It makes, for instance, the free surface would become like this. We are not going to do those things. In this course, this is the basic course on hydrostatics and stability. We will not do waves in this format. Very little of some trochoidal waves we will do at the end. But other than that, nothing more of waves. All the water lines we are considering are all in calm seas. Okay, so it will be like the first one I drew, the horizontal line. So that is what we are dealing with. Okay, then okay, so what do we have? Okay, so first we take a ship. Suppose we have a ship like this. What we say, this is the front part of the ship and this is the back part of the ship. So usually we call the front part of the ship as the bow of the ship and the aft part of the ship as the stern of the ship. So I'll just mention it, or it's better actually drawn, I think. This is what I said, a lot of problems. So we have a ship like this. Now remember, actually we'll draw the ship in a better form. This is how we draw it usually. Sorry, it didn't come properly. So this usually we draw it. See, just to draw a ship, I am taking so much time. This is the first time, so I hope you can put up with me for the first time. Like this. Okay. Oh, finally we got something. So this is how a ship looks like. Okay, the aft part of the ship. So this part of the ship is called the stern, and this is known as the bow. So this is the bow of the ship and this is the stern of the ship. This is also called the forward part of the ship, and this is known as the aft part of the ship, AFT. So the aft part of the ship and the forward part of the ship, and it is also called as bow and stern. And what usually you have, it is usually like this. You know, you have a thing like this, and here usually you put something like this. This is a propeller. So at this part of the ship, you put the propeller of the ship. You know, as the propeller rotates, it produces the thrust which drives the ship forward. So this is and just behind the propeller, you will have like this something here. This is known as the rudder. Rudder means, so I'll write here. Propeller, you would be familiar with what it is. It is used to produce the thrust required to run the ship. And then we have the rudder. Rudder is used for directional motion of the ship. That is for changing the direction of the ship, direction of motion of the ship. So you use the rudder. Rudder is also there. So here you have the propeller, and just behind that you have the rudder. Now, so this is, before we go into the details of stations and buttock lines and all, let us look at the basics terminologies of the ship. Then, so when we look forward of the ship, like when you look like this, if I stand here and look like this, you know, if the ship is there and I'm looking from the back, So this, when you look like this, the right part of the ship, so I cannot show it here, the right part of the ship is known as the starboard side of the ship, and the left part of the ship is known as the port side of the ship. So here we have the starboard and port side of the ship. So starboard is the right hand side and port is the left hand side. As you look from the back, as you look from behind, you look forward, you get this. So this is also known. Once you know this, then we will see port and starboard. Then yes, then we talk about something known as the principal dimensions of the ship. Let that ship be there. Okay, so then we have there is something which we call the principal dimensions of the ship. Now this is also known as the principal particulars of the ship. Sometimes it's known as the particulars of the ship. As you can guess, these are the basic things you need to know about a ship when you are starting to design the ship. The first one, of course, is the length of the ship. So the length of the ship, as this figure can show, there are a couple of lengths actually. It's not enough to say the length of a ship, because there are a couple of lengths which are used as in different different situations. We use these different names. One, there is something which we call as LOA. It is known as the length overall. This is the distance starting from here going up to here. The overall length of the ship. It is from the aftmost. So this will be the point. It will start from here and it will go up to here. This is the maximum length of a ship. Then comes something known as L. It is written in two forms, LBP or LPP. Both are same, perpendicular to length, perpendicular to perpendicular, or length between perpendiculars, LBP or LPP. So this is basically, now what does this mean? What we do is we can divide this whole ship like this. I am going to divide the whole ship into, if I have a ship like this, I am going to divide it like this. So these lines, or these planes, in fact, these lines are known as stations. Stations, okay, these lines. So basically we start from a station 0. This is not the station 0, it's drawn. I haven't described what is station 0 yet. Let's say this is station 0, this is station 1, 2, 3, 4, 5, like this, up to station 10, let's say. Starting from 0, it goes up to station 10. These are basically divisions of the ship. I mean, the whole length of the ship is divided into into these different sections. So the first one, the one at the aftmost side, is known as the aft perpendicular. Aft perpendicular. Aft perpendicular. This is the AP. This is known as AP. Then the one at the frontmost, the one which is at the forwardmost, is known as the forward perpendicular. Forward perpendicular, it is FP. So now we have AP and FP. So these are known as the two perpendiculars in naval architecture. In naval architecture, these are the two perpendiculars. There is an aft perpendicular and there is a forward perpendicular. Okay, so this is the aft perpendicular and this is the forward perpendicular, and the distance between these two perpendiculars is what we call as LBP, length between perpendiculars, or LPP, length from perpendicular to perpendicular. So you have So this is basically what is meant by a perpendicular and a length between perpendiculars. So we now see that we have, so you can see the distance is, it is not exactly the same. You know, the length overall is this whole distance, whereas the length between perpendiculars is only this. Now there is another length. Now, okay. Now the question comes, how do we define? So there is one more line here. I told you there's a line usually you have. I'll try to make this a little cleaner. Okay. So, so we
Excuse me,
have,
sir.
yeah.
Sir,
Yeah.
can you full screen the paint?
Full screen the thing. Okay. This is okay. I don't think I can make it bigger than this anyway. Yeah, this is okay. Is it okay now? Is it better? I think it's a little better. Yeah. Yeah. I think you can make this also a little bigger probably. Oh no. Probably it's better like this. Okay. Then so we have the half perpendicular, forward perpendicular. Now, yeah. Now we define. Now we have to see how do we define. See, this is the basic introduction, and the course is generally very easy, as it is said among the department courses. This is one of the easier courses, but people don't get good grades because I don't know, people take it too lightly. But there is one thing: if you don't know this contents of this course, you cannot do anything in the. Just hold for a minute. Just have to do one thing. Just a minute. Sorry.
Sir, you are muted. Sir, we can't hear you. Somebody muted you, sir.
Sir, you are muted.
Sir, we can't hear you.
Sir is not present there, I think.
He left the meeting.
Sir, besides the leave button, there is a microphone like button which is strike, no strike, and strike. At the left.
Sir, please click on the microphone button, sir.
Now can you hear me?
Yes, sir.
Yes, sir.
How? So
Yes,
how
sir.
did it seem to be so far then? Oh, it happened by itself.
No, sir. Someone has muted you. Yeah, I think so.
Oh. Okay. Anyway, now that's why you are in. Now you can hear. No, that's okay. So then there is no need for a headphone or anything. So that's what I was telling. I will try to bring that. So please don't do these kind of things. If somebody is muting me and all, that's all childishness. Don't do such things. Okay. So here you are saying, sir, we can't hear you. I guess you are muted. Okay. I cannot see your shared screen. That I don't know what to do. I don't know what this OneNotes can be done. Okay, so let's continue with this. I hope you can hear me now. If you cannot hear me, tell me. That's the right thing. Okay. Then how do we define? So as I was saying, how do we define the half perpendicular and the forward perpendicular? Now aft perpendicular, as I told you, here we have, it's like this, that this part alone I'll look at it. So this is how it will look like, the propeller. Okay, the propeller will have a shaft. It has a shaft. This is known as the shaft of the propeller, and it is connected to the blades of the propeller. There will be a propeller like this, and here there will be a rudder like this. So in front of the propeller or in behind the propeller, whichever way you are looking at it, so you will have a rudder like this. Now the rudder will have a center, and this is known as, and when you, this aft perpendicular is defined as to be going through the center of this rudder stalk. It is known as the rudder stalk, basically the centroid of the rudder. So that is where, so the line, the aft perpendicular actually is defined as going through the center of that. And then you have the, this is, so this is the aft perpendicular, this is the aft perpendicular, this is how it is defined. Then in the front here, actually it should have been station 10, but let's see, this one is known as the forward perpendicular. Now this forward perpendicular is usually defined as the intersection between the water line. This is the water line. Okay, just remember that term. Water line is usually the water line where the air meets the water, that interface. So water line, so where the water line meets the bow of the ship. So this is the bow of the ship, where the water line meets the bow of the ship, that region, that line, we draw a line there, and that line is known as the forward perpendicular. So when we get a ship, we define its aft perpendicular like this, forward perpendicular like this. We divide it usually into 10 equal intervals, and we call them, and we have usually starting from 0 to 10, you will have 11 stations. So this is a general method followed in hydrostatic, not in hydrostatic, in shipyards anywhere. And this is not so you will have these stations from 0 to 10 equal intervals, and the 0 as the aft perpendicular and 10 as the forward perpendicular. That is a mistake here. So it is not, this is not 10, this is 9, and this is 10. So you will have like this 10, you will have 11 stations. So as you can see here, there are 11 stations. Not to look at this. Okay, so these are basically what we mean by aft perpendicular, forward perpendicular of a ship. Then okay, after perpendicular, forward perpendicular, bow of the ship. Then we have, like we have defined, let's remove the whole thing. Then we have a couple of things. We have, as I told you, we talked about the length of the ship. So we had the length overall, length between perpendiculars, and remember I showed you a water line. So the length of the water line is also another length. That it is the length between the, where the water line touches the aft and the forward bow. Aft and bow, when stern and bow, when wherever they hit, though the water line hits those, that is called as the length of the water line. So you have LWL, LBP, LOA. These are the main lengths that we use in this section. Then of course you have the breadth of the ship. Now this is usually called as, in naval architecture term, initially it used to be called as beam of the ship. So you call it as beam of the ship. So it is basically implies the breadth of the ship. So usually, and it represents the maximum breadth of the ship. So it is the, and you should know that a ship, any ship, mostly we are talking about larger ships, you will have basically the maximum thickness, or the, not thickness, maximum breadth at the center, at the midship. So at the midship you will have the maximum breadth. Like the ship is there, it's usually around this middle region, that you will have the maximum breadth of the ship. So that is known as the beam of the ship. Then so beam of the ship. Okay, let that go. Uh, then the things that we talk about are three. So after length and breadth, we come to what is known as the draft of the ship. There are two spellings for this draft of the ship. It is usually spelled as DRAFT, which is the American spelling, draft, or it used to be called as draught, DRAUGHT, which is basically the British spelling. So the draft or the draught, basically both represent the same thing. So if you have a ship like this, now this is known as the draft of the ship. And this is known as the depth of the ship. These are two terms. As you can see what it means from the figure, I mean, I don't have to explain anymore what it is.
So can you?
Yes.
So there is a problem. You define the forward perpendicular where the waterline meets the bow of the ship, right?
You meet, forward perpendicular is where the waterline meets this thing. Yes.
The bow of the ship. As the load increases in the ship, so waterline changes continuously according to the load.
Yes, it is defined usually. Yes. That is a good question. Usually it is that I didn't mention. Now, usually all these things are designed for something known as a design waterline. Okay, there is something known as a design waterline, which is basically, actually, if you look at the ship, there will be a line drawn on the ship, on the side of the ship, one waterline, which is very important. Everything is defined with respect to that. So that is a question, right? I think that is what you are saying. Because the waterline can change, obviously. When weights are added to the ship will sink. In fact, that is what you are going to do in the rest. But there is something known as a design waterline, which is fixed. So, and this, as you keep, but the fact remains that as you keep on putting weights, the draft keeps on increasing. This is basically the Archimedes principle that is coming as the next chapter. So, as you can see, the draft will keep on increasing, and the depth will keep on. Depth will remain the same, and there is one more term here, this one, that is the depth minus draft. This is usually known as a freeboard. This distance, this is known as a freeboard. Please remember these terms, like when you are, whatever you are doing in the department, these are basic things, basic nomenclatures that you will need to know. So remember these things. Depth and draft and all is like draft is going to be the most important term probably in this course. So then the freeboard is something you should know, of course. Then we can have other things. There are some other things as well. For example, when you have like this a ship, usually you will see that the ship is like this. Okay, not like a U, a very faint. It's been highly exaggerated in this figure, but there is a faint decrease and an increase. So here, this is known as shear, SHEER. So this is known as shear aft, whereas this is known as shear forward. So there is a shear, that is that slight increase in this is known as a deck, and so slight increase in that shape, slight curvature, it goes up in this format. Again, I tell you, don't draw like a U or anything. It's nothing like that. It's just a very faint, very faint curve. So very faint this thing, and then similarly we can have another thing. Suppose you look at the ship from the other way around, like if this is the ship, suppose you look at it like this, then you know that you will have a section like this. This is what we mean by this drawing. It is known as a cross section. This is, so it's a little curved. This is known as actually a cross section. And here also we will have a water line. This usually you write it like this again, WL. Now this line also, this is the deck, okay? This is the deck. It is not usually like this. It is like this. Like this. It's slightly like this. The reason for that, actually, if you think a little bit, you can tell me what would be a reason to make a deck slightly curved like this? You tell me. Just think. It's a very simple reason. Actually, you can think logically. It will come. Why? What is the point of doing that? What is it? See, the reason is this. It's very simple. Usually, when a ship moves, due to some reasons, maybe there is a wind, there is a very strong wave, etc. Water can come on this. Water
Yes,
come,
so
and so when you have water coming onto this, it makes much sense if you have it like this, because water will just flow out like this. Okay, water will flow out, and it makes more sense. And by the way, the water that comes onto the deck while the ship is in motion is usually known as green water. The reason it doesn't matter, but it's known as green water, and usually to push the green water out, you usually have this thing. And this curvature that I showed for the side, this thing is known as a camber. Camber. You might have done in aerofoils. Okay, if you have done, I don't know if you have done. If not, you will be doing fluid mechanics this semester or next semester. I'm not sure. So in that you will come across this term very clearly, and this is known as a camber. The slight curvature is known as camber, and it is, the reason for that is, as I told you. Then